With audacious goals and a relentless drive, Musk's SpaceX has rewritten the rules of rocketry. They've achieved what many thought impossible: reusable rockets, dramatically reducing launch costs and opening up space to a new era of exploration and innovation. But how exactly did SpaceX achieve this incredible feat? What revolutionary ideas did they use to turn the space industry upside down? Stay tuned, because this is one space story you don't want to miss. In December 2015, SpaceX achieved a historic milestone by successfully landing an orbital Falcon 9 rocket booster back on Earth. This marked the first time in human spaceflight history. What makes SpaceX unique is its focus on reusable rocket technology. While other aerospace companies have been launching rockets for decades, none have attempted or achieved what SpaceX has done. To understand what truly sets SpaceX apart, we need to go back to the beginning. The first rocket boosters used to launch payloads into space were repurposed intercontinental ballistic missiles. For example, the Titan II, which launched NASA's Project Gemini, was initially designed to carry a nuclear warhead halfway around the world. As space exploration advanced, NASA developed the Saturn V rocket for the Apollo missions to the moon. Despite being a massive vehicle, only the small crew capsule at the top returned to Earth. The rest of the rocket was discarded, either in the ocean, floating in space, or left on the moon. At first glance, this may seem wasteful, but it was considered economically practical at that time. Building 12 disposable rockets for around a dozen missions was deemed cheaper than developing one reusable rocket. Even before humans landed on the moon, NASA envisioned a fully reusable space shuttle system. Wernher von Braun, known as the father of space travel, had a concept in the 1950s for the Fairy rocket, a three-stage, fully reusable system. This was meant to make human spaceflight sustainable, bringing booster cores down with parachutes and the orbiter gliding for a runway landing. While the space shuttle was considered reusable, it was more accurately termed refurbishable. SpaceX's approach is different from a commercial airplane's rapid turnaround at an airport. A plane unloads, gets cleaned, restocked, and refueled within an hour, meeting the true definition of reusability. However, the challenge NASA faced with the space shuttle was that, although it could technically be reused, the process of disassembling, inspecting, servicing, and reassembling the shuttle after each flight was intricate and time-consuming. The refurbishment of the space shuttle, involving about 650,000 hours of combined labor, happened concurrently rather than sequentially. Otherwise, it would have taken an impractical 74 years to refurbish one space shuttle. The key challenge with reusable rockets lies in making them economically viable. The frequency of launches needs to be high enough to offset the costs of developing and utilizing the technology. NASA's experience with the space shuttle illustrated the difficulties. Not only did the space shuttle require more refurbishment work than anticipated, but it also didn't fly as frequently as envisioned. NASA, due to the space shuttle's limitations, never had the opportunity to explore this fully. The commercial rocket companies likely hesitated based on the belief that if NASA, with its vast resources, couldn't make reusable rockets economically viable, then others would face similar challenges. However, SpaceX approached the problem differently and achieved success where others had failed. SpaceX's Falcon 9 design makes more logistical sense. From the early stages of its development with the Falcon 1 rocket, SpaceX envisioned recovering and reusing both the first stage booster and the upper stage vehicle. They implemented a propulsive return to the launch site and landing maneuver, setting the stage for a groundbreaking approach to reusable rocket technology. SpaceX initially aimed to recover both the first and second stages of the Falcon rocket, but they abandoned efforts to recover the second stage relatively early on. The second stage, being a simpler vehicle with one engine, small fuel tanks, and a payload platform, wasn't as valuable to recover as compared to the first stage. SpaceX chose a technically challenging recovery method for the first stage: propulsive landing. This approach was unprecedented and differed from earlier concepts like Wernher von Braun's Fairy rocket, which relied on parachutes for ocean landings. While NASA successfully recovered the space shuttle's twin booster engines using parachutes, SpaceX faced challenges with this method. The space shuttle boosters were small, light, and separated at a lower altitude and velocity. In contrast, the Falcon 9 booster had to impart much higher velocity to the upper stage, reaching speeds of over 8,000 kilometers per hour at stage separation. the energy involved was too much for parachutes to handle. Elon Musk's philosophy, reflected in SpaceX's approach, is to simplify and minimize components. Since the Falcon 9 already had engines, SpaceX opted to use them for controlled descent instead of adding parachutes. The engine served a dual purpose by also acting as a free heat shield during re-entry. SpaceX faced challenges and went through trial and error, with multiple upgrade cycles before achieving consistent success. The Falcon 9 reached its true reusability in 2018 with the Block 5 version. Unlike many rockets that maintain a consistent design throughout their operational life, SpaceX actively developed and upgraded the Falcon 9 to enhance its reliability and reusability, demonstrating the company's commitment to innovation and improvement in rocket technology. SpaceX's journey to create a truly reusable rocket began with the Falcon 9 version 1, a smaller and less powerful rocket at 46 meters in length with 1.1 million pounds of thrust. Although intended to be reusable, this version lacked the necessary components for recovery. SpaceX focused on ensuring successful launches before delving into recovery efforts. The Falcon 9 version 1.1 followed, growing to over 68 meters in length with 1.3 million pounds of thrust. It marked the first controlled return attempts, leading to the addition of landing legs and grid fins. While these early attempts weren't fully successful, they set the stage for future innovations. The Falcon 9 version 1.2, or full thrust, reached 70 meters in length with 1.7 million pounds of thrust. SpaceX experimented with cooling liquid oxygen and rocket fuel to increase energy density. In 2015, this version achieved the first successful landing of an orbital rocket booster, showcasing SpaceX's commitment to learning from failure. The evolution continued with the Falcon 9 Block 5, maintaining the same size but increasing total thrust to 1.8 million pounds. Visually identified by black paint on the landing legs, it focused on enhancing overall reusability. SpaceX upgraded turbopumps and strengthened grid fins with titanium. A thermal protective coating and a liquid-cooled heat shield at the base improved re-entry resistance. The Block 5 landing legs were redesigned for both extension and retraction. SpaceX also addressed issues with composite overwrapped pressure vessels, COPVs, linked to past incidents. These upgrades aimed to make the Falcon 9 truly reusable. Since its Block 5 iteration, SpaceX has demonstrated remarkable success. Booster B1058, for example, launched and landed successfully 16 times in just over 3 years, surpassing initial projections. Originally estimated for up to 10 launches, SpaceX now certifies Block 5 boosters for up to 20 launches, with potential for 60 launches and landings based on extensive testing. Comparing this to the Space Shuttle's 39 missions over 30 years, the Falcon 9 has shown itself to be an extremely reusable and effective rocket booster. The focus now shifts to the next leap forward with the Starship, as SpaceX continues to push the boundaries of reusable rocket technology. Well, what do you think about these SpaceX rockets? Leave in the comments. Thanks for watching!